Okay, so before we move back to physics, I want to kind of, spend a few minutes, discussing a few things about just one thing, very interesting aspect of the Fourier series. Okay, so let's take an example of a periodic function. So although Fourier series is used for representing periodic functions, what it really is for is to express well-defined functions defined on an interval, right? So for example, the function that I want to discuss is sometimes known as the square wave. So we have something that goes like this. So it's not a very nice sound wave. If you go to the Wikipedia page of it, you'll find you can actually listen to it, and it's not very nice. If you listen to the same the sine wave of the same frequency, it sounds much nicer. But this one sounds much harsher. Okay? But they're the same frequency. Okay? So this is square wave. Now I can ask, what is the Fourier series representing the square wave? Okay, so this is the periodicity. The periodicity is L. Okay, is it clear what I mean? What I'm doing here? So this is phi of x, and what we are interested in really at the end of the day, this part, which is the psi of x. But we are not going to quibble about that right now. So according to Fourier series, the Fourier coefficient C of n, we can find them doing this integral. So the integral was from minus L by 2 to plus L by 2, but because I have the origin in such a way, it's easier for me to do it from, it doesn't matter, how you do the integral. So this is the function, and to extract the nth coefficient, we multiply it by minus e to the power minus 2i and x over L d of x, okay? So we can do this integral. Now, for this function, what we have is that from 0 to L by 2, the function, we are going to take that function, say, to be 1. Yeah, let's call this 1. Okay? This is plus 1, and this is minus 1. So that this is going to be e to the power minus 2 pi I n of x over L d of x. And then from L by 2 to L, the function is minus 1. So that's what this minus sign is about. So here I have e to the power minus 2 pi I n of x over L d of x. So we basically have the same integral twice, but with a different sign in front and different limits. So if I do this integral now, what do I find is that 1 over L, and over here, the first integral gives me e to the power minus pi I n minus 1. And the second integral gives me e to the power minus 2 pi I n minus e to the power minus pi I n. Okay, so if you stare at this for a few minutes or even less than that, you will find that C of n is then given by, so the coefficient now is no longer 1 over L because it's actually minus 1 over 2 pi I n. Okay, so if you stare at this, you find that the integral is -2 if n is odd. Okay, and it's 0 if n is even. Okay, so let's see how this comes about. If n is odd, then this is -1, right? And this is also this factor is -1, so -1 will give you +1. But this is always +1. So, whether n is 0 or 1, even or odd, this is always +1. So, so when n is odd, we get a -2 here, we get 0 here, and we get +1 here. And the +1 -2 gives me sorry, +1 -2 gives me hang on, did I make a mistake? Yeah, I think so. Hang on. Oh yeah, sorry. Yeah. So this is -2. This is +1. This is +1, and this is if n is odd, this is -1, right? So -1 minus this minus gives me +1, and this is when n is odd, this is +1. So this is 2, right? And let me just see if I can. I think I made a mistake in my calculation. Okay, so let's just figure it out. So this is the most exciting part of the class when I make mistakes. So E minus 2 pi x over L divided by L by 2, 0, right? So if I put x2, the 2 cancels this 2, and I get e to the power minus pi I n, right? And okay, does that and here we have the L has so in the denominator I have minus 2 pi I n L. Okay, and can you guys hear me?
Yes.
Okay. All right. Please let me know if you detect any error in my calculation. Okay. And the second, so the first term when we put x equals to L by 2, the exponential becomes minus pi I n, and this L cancels this L, and we factor out 2 pi I n, and that is this guy, right? So this guy is fine. So when x is equals to 0, this whole thing is just 1, right? So we get -1. Okay? And the second integral is exactly the same, except that we have L and L by 2 as the limit. So if I put L in over here, what do I get? I get this L will cancel this L. So we have e to the power minus 2 pi I n, and then minus L by 2, then I basically get this thing, right? So I think so far that this is all right.
Is it that if you take a minus 2 pi I n out of both of them, then wouldn't you have a plus in the middle?
Yeah.
Is that...
Thank you, Sai. Yeah. Well, no. Why? Yeah, I would have minuses both. No. That's not true. No. because in the denominator here, I also have a minus 2 pi I. Okay? Yeah, no. I thought you had saved me, but you didn't. Okay, so, and then I have minus 1 over 2 pi I n. And now let n be an odd number. If n is an odd number, then this is minus 1, right? And this is minus 1. And then minus, this is always plus 1, because this is 2n is even. And then we have minus 1. Okay? So, okay. I think okay. And if n is, okay, if n is, so this is odd, but if n is even, what do we get? If n is even, then we get, this is plus 1, right? Plus 1 minus 1 minus, this is always 1, and this is plus 1. So if n is even, we get, these guys cancel out. And okay, so this is a problem because we are getting 0 for both cases, which is not supposed to be the case. So I must have made a mistake.